You're good to see my screen.
Yes.
So yesterday we had discussed the transformation up to map values, I guess, or not map values, only zip, right? So let me copy from map value to some next. This one. If you look at it, let me start this as well. Why this is not? Let me first detach. Okay, this is available. So if you look at map values, see there are some transformation which are dedicated to RDDs only, and not for data frame. But of course, you can use that with data frame and data sets both, but maybe with some other way, with some alternatives, but and not in its original form. Okay, because you already understand about its low level, high level API, how they have been designed internally. So this is map values, and if we talk about this first, then this map values apply a function to each value in a key value RDD. As of now, you understand that okay, you can take some data and you can create a RDD from that, but you can have a key value RDD. Key value RDD is something where you have data in key value pair. Yesterday we seen the example where let's say we are creating a RDD with this kind of data. 1, 2, 3, 4, 5. This is not key value, right? This is simple data. And from that data you are creating and then you are trying to do something. But here we are talking about key value RDD, and most of the transformations are dedicated for key value RDD, where this is helpful in variety of data. Let's say you are having some map data or you are converting the data to map. If you are, let's say you are having a data frame, you converted that to RDD. From that RDD, your column name will be key and then the rows value will be the value for that key. So if you are converting into RDD, then based upon the key you want to extract something, in that case, these will be helpful for you. Or you are having the JSON data and all, and that data you are converting to key value RDD, and then you are doing the extraction for the either the key or either the value or doing some aggregation based upon the key. So we are going to use this. Then we have keys. This is return the key from a key value RDD. Let's say you are having a JSON data, you converted that to RDD, means key value pair RDD, and you want to extract only key from the RDD. Values, only the value from the RDD, but not key and value both. Then partition by. Partitions the RDD based upon the specified partitioner, okay, with the numbers you want. Then Cartesian. This is returning the Cartesian product of two RDDs. If you are having two RDD and you want to get the Cartesian product from that, then we use this keyword, this transformation. Then we have college. So this college I will not discuss now. I will remove it. Okay. And let me take here where is college and repartition was above only, right? No, repartition is not part of that. Okay. Let me keep it here. Anyways, I will take it later because this is a very important thing which we will discuss with repartition also. Okay, so this is the college. College is to reduce the number of partitions without full shuffle, because we know how shuffling impact the processing part. If you are having good amount of data, then because of shuffling, maybe you are having very low level means logic is not too much complex. That's very simple logic, but because of data and because of a single shuffle also, this will be impacting, because data is going to travel from this node to this node, and then finally they are traveling from worker node to driver node and all. In this process, that is going to take lots of time. This will be impacting the performance. Then we have take. Take is to returns the first n elements from the RDD. This is just for sample. Yesterday we were doing some sample with the fraction percentage, right? Like that, let's say you are having some billions, millions and billions of records, and you want to just check out what is the kind of data exist in this partition or exist in this RDD. In that case, simply you can take, or you can use this take. This is going to take some random number from the first elements, and this is not going to scan the entire data. So there will not be any shuffling or any kind of check. Simply randomly it will be picking the data, so that will be quite faster. Then first is also similar to take only. This is also used for sampling itself, but returns the first element of the RDD. This is making sure that this is picking up the first one, and this take is for first n element. So you can see this, there is a number how many records this is taking. That means this is going to take the parameter, take 5 records, 10 records, 20 records, like that. But with first you have no parameter. This is just going to pick up the first. Then is empty. Is empty is something that is very crucial for your development. Whenever you are doing any development, then we should adopt the best practice. What is the best practice we are going to adopt, right? Like, let's say you are having a data frame and you are just trying to process. And based upon the data frame, you wanted to add, means you wanted to manipulate. Okay, let me give example. Let's say you have a data frame, and data frame is having a date column in YYYY, MM, DD, then hour, minute, and second. This is the value. Means this kind of value you are going to get in your column, date column. Now you want to manipulate a column that would be kind of a load date. And in this you are going to extract only YYMMDD, YMMDD from this existing column. Okay. You do not want this hour, minute, second. In that case, let's say you are having a data frame, and data frame is always having the data. And whenever you are doing the manipulation, that means you are creating a new column based upon this date column. It is not failing anytime. It is good to create a new column. But tomorrow, if this data frame itself is empty, and when you call this action, what will happen? It will be, it will get filled with the error, right? So in that case, it is good to have each empty check, because if you are checking each empty, then at the first step only, if there is no data, your job will quit without checking anything else additionally. If you are not checking, then what will happen? Unnecessarily, this is going to do some kind of transformation, whatever possible, with the empty also, because maybe sometimes you are having two data sets, three data sets. You are doing something with few data sets, and finally you are going with the main data set, and that is empty, and because of that you got the failure. So in that case, unnecessarily this took up some resources, this took up some time, and finally you got that it is empty, and unnecessarily this is going to fail with some kind of error. And again, if you want to avoid some error, let's say this column, if you want to do, okay, if data is empty, then this will fail, because this date column itself is not having any kind of data. Then with blank data, this can't be extracted. This is looking for that kind of data with in this format. In that case, you can check, okay, is empty, then don't do this. Then what you do, you can take, okay, current date. Okay. That means if is empty, then populate this column with current date. If not, then extract from here. Kind of that means we can have some mix up logic. Or better thing is, if you have some if your main data frame itself, if your main data frame is empty, and based upon that everything is dependent, then first check out, and if that is empty, quit the job immediately without checking anything else, and wasting the time, resources, and everything. So this is a good thing if we are adapting in our real time exercise, and that will be a kind of good practice, that you are checking everything in advance to avoid lots of failures and all. And then we have slice. Slice is to return a new RDD containing a subset of elements. You are having a data, and then you are making slides from there, and then you are returning kind of doing the slicing for the data. You can understand with that. Then intersect. I understand that you people are from mathematics background, right? Anyone who is non-mathematic? Okay. So you people are non-mathematic or what?
I think we did engineering, so it's little bit mathematics.
Okay, but you are right. You people are learning data engineering and completely silent. You are going to face a question. Do you know what to say? DSA, data structure. What you are going to reply?
Uh,
Okay, no, sir. So this intersect maybe you have learned sometimes in your mathematics as well, right? Intersect and all. Anyways, that is a simple thing in your coding also, but you can relate if you have in mind. Okay, so let's see this one by one. So this intersect returns the intersection of two oddities, just like your mathematics only. Okay, so I will do the comment and then I will take it one by one. So I will just copy from here and this is map values. Okay, so I will just comment out all the things. Otherwise, this will be printing up and we will not be able to finding. Okay, here if you see, we discussed first about a map values where we are having key value RDD means pair RDD. Here you can see I am creating a RDD with this is the key and this is the value. You can have this kind of data. You can assume this is your kind of map, or you are having a data frame. You are converting back to a key value RDD, or you are having JSON, and from that JSON you are creating this kind of RDD within memory data or maybe with the files data with source data and all. So using parallelize, creating this sample RDD and then map values result. Then we have this transformation map values. Then using lambda, you want to do something. So let's say you are just doing, you are trying to do this calculation and then collect. Then map values result. If you do this, then this is going to apply over the each key value. If you look at the output, what is this? This is A 2 and B 4. Okay. If you look with the data here, this has multiplied two values, right? 1 into 2, 2 and 2 into 2, 4. Correct. Key is same. So for each key, what is the value? This has did the multiplication. So this is for the entire key value. Now, if you want to extract, let's say you are having a map and you want to check, okay, what all keys are existing there. You just want to check the key because maybe based upon the key, you want to do some kind of comparison or you want to run some loops and all. In that case, your requirement will be only the extraction of key. And in some condition, you can have a requirement to extract the values only, maybe based upon that values you are doing some kind of analysis. In that case, you are having this transformation rdd dot key simply, not nothing else. And for the values, rdd dot values, that's it. If you run this, then for key means a and b and for values means 1 and 2. If you see the output here, we have already run this. You can see key result is A and B and value result is 1 and 2. So this kind of requirement you will be doing with this transformation map values key and value. Then next we have partition by. If you see the partition by, then partitions the RDD based upon the specified partitioner. Again, this is the part of wide transformation. Okay, that means this is going to shuffle the data, either a small amount of data or full data. That will be depending upon the data and the entire logic, but this will be part of that. Then assume that again you are having key value pair RDD. So AC dot parallelize, this is your data. Okay. And with this data, whenever you are creating the RDD and you are specifying any number here with comma separated, that means that is your original RDD, and in your original RDD you are defining a number for the partition. Okay, yesterday we had seen that. So here if you are doing one, that means your original RDD is having one partition, means you are defining with one partition. If you want 10 partition, you can define 10, then your original RDD while creation, it will be having that many number of partition. Then so here we assume that okay, this data is coming with one partition only, and then you are doing partition by. Partition by means you are now creating the partition any number. You here we have provided two, that means two partitions. Okay. So here, what is the main thing? Main thing is you are having the data. With the data, whenever you are loading the data, then by default it will be taking some partition number based upon the Spark configuration, Spark setups, and all its internal, according to its internal logic, that is going to take up the default number of partition. So here with this example, we just set up a number one. That means okay, while reading we are assuming that we are having only one partition, and then out of the source number of partition which is in the source data, we can create any number of partition, because we are going to work in parallel mode, and for parallelism partitions are required. If you, let's say you are having 1 GB of data and that is having only a single partition, then single partition will be sitting to single worker node, and single worker node means all the things, all the workload will be over the single node only. Then how that is going to benefit you for the parallel processing and all. If you can split that into multiple partition, then they will be distributed over multiple nodes, and that will be help to get faster processing and all. So that is for the partition by. And okay, so this is the example. Okay, partition result. Here we have, I have taken glom. This is just a keyword. Sometimes we use it for different thing for the numbering. And then partition by result. Let's first print it, then we will see. So if you see the output, what is that? We have given two partitions. So this, it is taking one blank, and with one this is taking the data. Okay. If you, because there is no enough data. Okay. Let's have some more data, then we can see. Because for partitioning, data should be with good amount. Otherwise, we can't take it properly. C and D. Just let's see this. Okay. Now C3, A1, B2, D4. This is one, single one. No, no, no. In one, it has taken C only, right? And in another one, in another partition, this took this all three. So this is distributed internally accordingly. That means it has divided into two partitions. We can check with num partition. Yesterday we did that. And if we do with one only, then we will be getting single partition. If you see now, all the data is in a single only. Is as a single list you can see. And if we do 4, that simply you can distribute the data. And whenever you are doing the partition by, that means redistribution will happen. And when redistribution will happen, that means data will suffer. That's why this is in by transformation category. When I did 4, it has taken 1 and 2. This is 1, then this is 1, and this is 1, and 1 is coming with blank. That means one of the partition is not having any data, because one partition contains 2. This one, this is having 2 records. So like that. Then what was next? So okay, here we have gloom, right? RDD data gloom I had taken. So gloom is a kind of when we wanted to inspect the element for each of the partition in RDD by grouping all the elements in a partition into a list. So this is especially useful for debugging and understanding how data is distributed across the partition. Whenever we do RDD.gloom, and then it will be means gloom simply doesn't change the number of partitions in the RDD. Whatever partitions we have defined, or it is in that is by default, that will be. And each partition's elements are grouped into a single list. When it is returning, that means it is going to return the nested list, and this is useful for debugging. If you look out the output, you can see that, okay, nested list inside the list. And if I need to see if that will work or this will fail, just let me run this. Okay, this worked. So here you can see the output differences. This is a list, right? But using Gloom, it was extracting with the nested one. Here it is giving the information about, okay, how many partitions are there for one of the partition this, for one of the partition this, for one of the partition this. But whenever you are removing this gloom, then this is simply taking out the normal data, and you are not getting the information that how data is distributed between the partitions. That information is missing finally. You can compare that here. Here there is no information that which data is distributed to which partition, or how many partitions are total, and how data has been distributed. So if you are looking for debugging and all, then this gloom is helpful. Okay, then we have this next one. Let me comment out previous one. Okay, then we have this. Here we have two RDD. One is for the one we are creating with the number A and B, and second we are creating with some letters A, B, and C. Then we are looking for a Cartesian result where we are saying RDD1 dot Cartesian RDD2. Simply just like a join. If we run this, what will be the expected output? Any guess? If you have did similar kind of work. Okay, what it tries, it has tried to match each number with each of the letters existing into the second one, right? So in previous one we had 1 and 2, and in second one we had A, B, C. So one is matched with A, one is matched with B. Again one with C, and okay, one with C, A, B, C, and 2 is also A and B and C. So all the numbers from A or whatever product you have, whatever elements, words, characters, letters, whatever you have in the data, that is means each element of a first RDD is going to be joined with the or going to make the pair with the second RDD each element. Okay. So if you have anything like that, you can go for the Cartesian. And again, this is also very costly transformation because everyone needs to communicate with each, right? This A, this needs to make a pair for A also, B also, C also. Maybe in the real time there is thousand of items are there, and all thousands are sitting to different nodes. So it needs to communicate with each one. Then finally it can return the final output. Okay, that this is the final output after pairing with everyone. Because of that, this will be a costly transformation, and that is going to impact the performance. So if you have uh, means if you have anything where you can manage, or you can do the same with some alternatives, and really you do not need this, then you can avoid it. If anyway anyhow you need this kind of output, then you can see if you can implement with some um, alternatives, if that is helpful. If not, then you see how much requirement is for this output, whatever output you are going to generate. Until unless if there is no really requirement, don't go for this is going to impact the performance and all. This is also coming to avoid transformation. Next we have coalesce. So this is a very hot topic for the interview, I can say, this coalesce. So coalesce comes with a pairing up repartition. Anyways, we are going to discuss that coalesce and repartition in very much detail, but here I will be giving some overview for just for this example. Coalesce and repartition. So coalesce and repartition both are used to increase or decrease the number of partition. Let's say you are having a 10 GB file and you are processing that. For processing, you will what will be your requirement? You will be thinking that okay, if I can split that in multiple partition and that can be distributed over multiple nodes, then my processing will be faster. Okay. In that case, you need to increase the number. Even with repartition also you can increase the number. With coalesce also you can increase the number. You can say df dot repartition, let's say 5 or 10. Then your data frame is going to repartition with number 10. Similarly, you can call this one also instead of repartition. Then what is the differences between both? Difference is this repartition is costly. This coalesce is much better in performance. Okay. But the advantage is if you are calling repartition, that is going to make sure that data is evenly distributed across the nodes. If you are calling for the 10 partition, then maybe 100% data is not equal, but 99%, 95% it will try that data is getting distributed evenly between the nodes. And if you are calling for the coalesce, then internally process is bit different, and this is not going to make sure like how repartition is going to. I'm not saying that in coalesce there will not be any redistribution and it is not going to shuffle the data. It will, but not like repartition, because repartition will be making sure that you are getting this. You are getting the data distribution evenly between the nodes and all. Okay. So that's why this cause lots of shuffling, repartition. And coalesce doesn't do that. Internally, this is designed in a way that, okay, this is taking the nearby partitions and taking the data together. This is not taking care as the data was distributed evenly with the nodes and all. Someone is having more, someone is having less, like that. Because of that, coalesce is kind of lightweight. You can if you are comparing with the repartition. So when both can be used to increase the partition, both can be used to decrease the partition, then which one we should use when? The answer is whenever we are trying to faster our job. Then let's say you are having 10 GB, one file 10 GB. You are looking for the processing. What you are looking for? Your main aim is faster processing. For faster processing, you would like to split the data into multiple partition, and you are going to think that okay, this if I am doing the repartition, that many if I am doing this 10, then I am assuming that okay, if I am having 10 worker nodes, then one partition should be uh, send out to each one, and then it will be processing parallelly, and then my processing will be faster. And if your data is distributed evenly, then that is more better, because 1 GB data with what each of the node, so everyone is going to take almost a similar time because data volume is much. Just assume that you did 10 partition, but one node has 2 GB of data, one node is having 4 GB of data, and one node is having 50 MB data or 500 MB data. What will happen? Which is having 500 MB data, that will be completing its processing very much faster, right? Within few minutes or few seconds. And which is having GBs of data, 2 GB, 4 GB, that will be taking lots of time. And because of that, there can be a blocker, because if any node which completed the job faster, within few seconds only, that is also not going to produce the output, because output can't be taken based upon a partition output. All the partitions should complete its job, then finally we can aggregate the output, and finally we will have output. So if one node is having a small set of data, one node is having bigger set of data, that is going to impact. One will be quickly completing the job, and that will be sitting idle. Another will be having more workload, and that is going to take lots of processing time. Then why to do that? Why not to distribute the data evenly, so all will be having same workload, and they will be completing the process at the same time, almost the same time, not exact same time. And again, resource utilization and all will be same. Otherwise, which is having less volume of data, that resources will be idle after few minutes or few seconds once their processing is done. In that case, you can go for the repartition. And collapse means this is good for decreasing the number, because this is not taking care for a even distribution and all, but for the processing, for the better performance, you need data to be distributed with the equal amount, almost equal amount. So repartition is benefited there. This collapse is not better. This collapse you can take while decreasing the number. Decreasing the number in the sense, let's say you processed a 10 GB file with 10 repartition, all processing done. Finally, you want to write this output as a Parquet file. That Parquet file, how many output you want? Are you looking for 10 output files? Or you are looking for 5 output files? Or you are looking for a single file? So in the real time, we do not create lots of files. You already know small files is general, right? And also for the delivery wise also, single file is more better. Of course, if you are having GB and terabytes of data, you are not going to create a single file. That will again create issues for network transitions and all. But you can plan for okay, up to 5 GB you can create one file, and if you are having 10 GB of data, you can create two files. And there you are not caring how this is dumping the data to the partitions, because your processing is already done, and main worry is for the processing part only, that our processing should be faster. In that case, you can go for the college. You can say okay, while writing the file, uh, you can define the number. So this is the main differences. You may get questions, what is collapse and repartition in a Spark, what is differences between both. So both are used to increase and decrease the number. Both can be work in the same way, but internal structure is different, where collapse is going to redistribute the data. Just give me 1 minute. Huh? So when this question is coming up for coalesce and repartition, you can say that both are used to either increase or decrease the number of partitions, but internally it behaves differently. So coalesce is better for reducing the number of partitions, and repartition is better to increasing the number of partitions. Now you know the reason, because repartition we use for increasing the number, because we want to distribute the data between the nodes, between the partitions with equal amount of data, so all will be having similar workload and they will be processing the job almost with the similar time. Not like that one got completed very quickly and one is taking lots of time. Because of that, we prefer repartition, increasing number of partitions during our process. And coalesce performs a narrow transformation. Narrow transformation means minimize data shuffling. I'm not saying that this is not going to do shuffle. This is going to do, this will do, because of course data movement will be there. If you are saying, if you are reducing the partition also, reducing means if data is deciding to, let's say, 4 nodes. Out of 4 nodes, you are saying coalesce 2. That means data is going to be managed with 2 partitions only. If you are saying partition 1 means coalesce 1, then that is going to manage the data with single partition only. But this it will be minimizing the data shuffle, because internally this is not behaving like repartition. This is not caring for the data distribution like how repartition is caring for equal data distribution. So because of that, this coalesce comes under narrow transformation and repartition comes under wide transformation. So this minimize the data shuffling and best used when reducing the partitions. Let's say you are having 10 partitions already, which is running, means your job is running with 10 partitions, and you had made it for getting parallelization and faster processing and all, and finally you did it, and now you want to reduce the number of partitions for some other kind of use cases. Let's say writing the file. In that case, you can go for the coalesce, and repartition, it can again increase or decrease the number of partitions, as I said, and it performs a wide transformation. That means it is going to involve a full data shuffle, not minimal data shuffle like coalesce. And best used for this is evenly redistributing data or increasing the partition. Whenever you are thinking that your data should be evenly redistributed, then you are going to use repartition. And how this is doing full shuffle means, let's say your data is sitting to 3 nodes and you are saying repartition 10. Then from 3 nodes, data is redistributed. Data will get collected all together and then data is going to move. Okay, this much data should sit to this node and this much data should sit to this node. And it will be making sure that, okay, all the nodes are having some if not 100%, at least a similar amount of data, and all are sitting to different nodes, and then this is doing the processing. That means this is going to redistribute the data across the nodes, and that's why this is going to acquire full shuffling. So most of the time when you are looking for the increasing the partitions for the processing purpose, you go for the repartition. When you are looking for decreasing the partitions because of some other use cases, including writing the output data to files and all, we use the coalesce. In real time, if I talk about real time, most of the time, while all the uh, processing part, we use repartition, and we use coalesce mostly while writing the file, writing the data back to the target directory, target location. We use coalesce. Okay, then let's uncomment this. Here, what is this? You can see here, reduce the number of partitions without full shuffle. So this is narrow transformation. As this is not doing full shuffle. Sometimes it may be wide as well as it may involve a shuffle if the partition needs to be merged, because you can have multiple logics, multiple use cases, right? So let's say you were trying to merge all the partitions, merge all the partitions. Let's say you are having 10 partitions sitting to 10 nodes, and you are looking for finally one coalesce one. That means all 10 data should move to one place, right? That then only it can be merged. So it can be wide as well, but it is more better than repartition if you are looking for optimization wise. But again, each case is different, so no one can be comparable that I am using coalesce, then I will use this one only and I will avoid repartition. We can't avoid because repartition is having its own advantage that is useful for the processing part. Here, for the example, we have RDD and RDD. Let's say we created RDD with this data, and we are defining number of partition 3. That means this RDD will be created with 3 partition. Then the result college 2. Let's first print this. Okay, let me run this only. I hope that as of now you are good with the GLOM. This is for the internal structure. So here with the GLOM means it is saying that data is having two partitions. Okay, but in one partition this got this data, and this in one partition this is having these elements. Now if I remove this college 2, then let's run this. This is having 3. How 3? Because while creating the RDD, we gave 3 partitions, right? So this with its default nature, this is coming with 3 partitions. But when we do coalesce, that means it is trying to reduce the number of partitions with number 2. Then data will be redistributed with 2 partitions. Then we have a repartition. Here I had mentioned repartitions also to match with the exercise. So repartition. This is reshuffles the RDD into a specified number of partitions, and this is the part of wide transformation. RDD we are creating. This is the RDD, and we are creating 2 partition equal to 2. This is the original one. Now we want to repartition. RDD dot repartition 3. Okay, that means this data will be divided with 3 partitions. That means we are trying to increase the number of partitions. Originally it is having 2 and we are trying with 3. Here you can see repartition result. One is this, second is this, and third one is empty. Anyway, this is very small amount of data. And this is Spark and all, right? So this is always good for good amount of data. Then only you will be getting the realistic picture. So whenever you are trying, you can try to take at least a 10 GB, 10 MB, 20 MB minimum. If possible, if you are having data with 1 GB and all, you can take up that and then you can do all the exercises with that. I believe that I had shared a code for generating the random data. Did I share? One day I was discussing about that, right?
I need to check.
Okay. If you are not having, then you can let me know. The target is only to generate the random data so you can do your exercises properly. Then this is the next one. Okay, let me comment out. So this point you can note coalesce and repartition. Okay, because most of the time this can be part of your interview discussion. I am not saying about 100%, but this will be part. I can say 50%. And again, maybe question can be indirect, not direct. Direct question can be, okay, what is difference between a repartition and coalesce? This question you may face. Another question is what kind of optimizations you applied in your application, in your program, whenever you are doing the development. Then indirectly questions are coming to you. You can talk about I take care for the narrow transformation to avoid shuffling, unnecessary shuffling, and wherever required, then we do wide transformation. Whenever we are looking for equal distribution of the data to make sure that processing time is uh, good and none of the resources are sitting idle and all are having same effort for the processing time, data processing and all. Then we go for repartition. When we have to reduce the data, let's say for writing the file to the target location, then we go for college. So these points you can mention in your optimization topic as well. Okay, because optimization is the necessary question that will be part of your Spark interview, and this question repartition can be 50-50. But it is having more probability. Then a take means first n number. That means this takes a parameter, one args. Okay, if you see its original definition, then you can see here, if you look out, parameter one, it is having a number parameter that is int, and that will be taking first number of the elements, how many number you are defining. So if you, this is the 1 2 3 4 5 6, this is the element of the original RDD, and here if you compare with the previous one, this one, here in this RDD you were giving the number of partition, here you are not giving the number of partition, then this will be getting created with the default number as per Spark. Okay, you are going to take the sample with 3. What will be the output? Any guess? This is taking 1 2 3 first number, right? So how many numbers we are giving, this will be taking that. Similarly, you had first means this will be also picking up the, this is also picking first only, but with parameter, with the number how many, 1 2 3, and with first you do not have any parameter. This is just going to take the first. So if you want to do the sampling with first element itself with no more numbers and all, then you can go for the first. So this is only the little difference between the first and take. First means 1. This doesn't matter whatever the first element is, and this is not going to take any number, that how many numbers you are looking for. Then you have collect. I guess that we are doing all the exercise with collect only, right? Collect means collecting the data to the driver node. Here you can think about collect. Collect is the costly operation in the Spark. Okay. We should always avoid doing the collect, because collect means that is an action that retrieves all the data from a distributed data set. Let's say either this is RDD or data frame, and brings it to the driver node as a list. If you are working with Python, then Python list. Okay. So what it does internally, it is going to fetch all the data. It gathers all the partitions of data set into a single list on the driver. Let's say your data is distributed to 10 worker nodes. Then this is going to collect data from all 10 worker nodes and putting that to driver node, from worker node to driver node. And then driver memory limitation. Let's say in the cluster, first day we had discussed about, with your cluster you are having, let's say, one master node and master node or driver node, and you are having some setup of worker nodes, let's say 10 worker node, 20 worker node, whatever you have uh, provided to your Spark job. What is your expectation? You are expecting that your actual processing should be happening to worker nodes and not the driver node, because driver node is the single node, right? And you are having multiple worker nodes. That means worker nodes are having more capability to process the data, store the data. Driver node is the single one. That means it is having less capability. If you are having 100 GB of data, you are working with the 10 worker nodes in the distributed mode, then that is fine. And if you call all 100 GB data to a single master node, then that is not fine. That may fail. And again, in the real time, we always try to make sure that all the processing, storage, and all are going to done with the worker node only, not with the master node. So what we do whenever we are doing the resource utilization and all, we, let's say I am taking 5 executors, then I can give some 20 GB for each of the executor. And for driver node, if you were a good developer and if you are doing the development in a proper way, then 4 GB should be okay. If you are having some kind of loggers and all more, or you are doing some kind of collect for some sampling, then 6 GB. And I believe that 8 GB should be enough for any driver node for any of the application if your code is fine. Otherwise, if your code is not fine, unnecessarily you are collecting the data, unnecessarily you are keeping moving the data from worker node to driver node, then that is needing more memory. But as a good developer, we should make sure that we are adopting all the best practices, and we are making sure that we are not going to unnecessarily call the data from executors to means worker nodes to driver node. And in that case, 6 GB to 8 GB memory for driver node is always enough. But again, condition is if you are adopting the best practices, then only. Otherwise, you are going to get the error out of memory exception. Here what happens, let's say you are having 100 GB of data and you collect all the data, all 100, let's say I have given 10 GB to my driver node or 8 GB to my driver node and 20 GB to my worker node. So my worker node is having enough memory and my processing was happening properly. But I collected all the data. I did collect data frame dot collect or RDD dot collect. Then this is going to collect all the data to driver node and I have given driver node 8 GB only or 10 GB only. Then how it is going to take up all the data? This is out of capacity. Okay, this is going to fill without of memory. And again, if that is not the case also, then collect is very costly because as this is going to pull all the data from the worker nodes and uh, gathering all the data together and keeping to the driver node, this is very much costly and we should always avoid that until unless this is really required. And what can be the requirement? Requirement can be, let's say you are having 100 GB of data you are processing, you want to do some sampling, let's say for your debugging and all, for each of the transformation you wanted to print something in the logs. So at the debugging time that can be helpful for you. So you can take some, let's say take 5 above we have, right? Take 5 or take first and then you do collect. So this will not fail because take 5 only means you are going to take first 5 records and then you are going to do collect. In that case that is okay. So whenever you are looking for collect for some debugging and all, in that case, you can make sure that you are collecting very minimal data, not much data. Then you can avoid failure. Otherwise, for sure, you are going to get out of memory exception. Okay. Then let me comment out all these. If you have any question, just let me know. Okay. So this was about collect. Simply, we are doing the collect whenever we want to get the data from the RDD. We are doing the collect, and collect means this is pulling all the data from worker node to driver node, and then we will be getting the data. So, uh, what happens internally for large data sets as it is pulling all the data to the driver node? This will be causing the memory issue. So, we should always go for the alternatives. Alternatives can be take with n number of parameter. You can take, you can say take 5 or you can go for the first, or you if you are working with the data frame you can do dot show and you can have the limitations. You can think for the alternatives. Let's run this. What take does? This is simply collecting the output, okay? Nothing else. And where Cartesian output is getting printed, this one. So let me comment this one as well. Now we have is empty. I will uncomment this. Is empty, check if the RDD is empty. This is a good practice. Before moving ahead, we can check either this is empty or not. Let's say I want to do something on top of this RDD. I want to do a simple, I want to do some take 5 or take 3. If there is no data, what this will take? Not means unnecessarily this is going to perform one of the transformation. So this is a good practice. If in advance we can check if is empty, then quit the job. If there is the data, then only do further processing. So let's say I am having an empty RDD. I am doing the parallelize, but in this list there is nothing. So this is an empty list. There is no data. And I'm creating one of the RDD with the data. Here I am having some data. Then empty result. RDD, empty RDD is empty. Then you can have your empty result and non-empty result. Then when we have RDD with data and then check the is empty and then print both how you are getting the output. True and false, right? So empty result is true. This was empty RDD. So you get true. Non-empty result it was false because this is having the data. So like that, we can have our use cases. We can see, we can check first if that is if empty, then we can simply quit out. If that is not empty, then you do whatever you want to do further. This is up to you, whatever transformation we're looking for. Okay, so that we can do. Then let's come to next slice. For slice, again you are having a RDD. Then yesterday we had discussed about zip, right? This is zip with index. This is one more transformation. So slice result equal to RDD dot zip with index, then doing the filter. And based upon that, we are collecting the key, either key or value you can say. This is dot key. Above we had discussed about, right? Dot keys or dot values. So first let me run this. As of now, let me comment out this one. Let me run this first. Okay. So slice result is 2 and 3 and 4 because there is a condition. Okay. And based upon the condition, this will be getting like this less than or equal to, or sorry, this is taking greater than and between 1 and 3. So this is taking 2 and 3 and 4. Okay. Just give me 1 minute. Less than 1 and less than equal to 3. Okay. So if we look at this slice one, then slice one we are going to use with the GP with index, and then we can filter the desired range, whatever range we are looking for. Here we are providing a range, right? With this range, you are going to take up the output. So we are going to filter based upon where a slice from index 2 to let's say x equal to, here I am giving 2 and then equal to x1, and let's remove this equal symbol. Let's take 5. Then we are looking for slice from index 2 to 5. And let me just run this. We'll check it. How this is behaving. Okay, yeah, 3, 4, 5. This is okay. If I remove this equal symbol, then this is taking 4 and 5. Okay. Yeah, so this is just to define the range. Whatever range you are looking for, with that range you can do the slicing. And here zip with index you are calling for the assigning indices to the elements. This is going to assign the indices first, and then based upon the indices, this will be making the range for you, and based upon the range you can do the filtering. Then we have intersect. Intersect is as I said, if you have most probably in this was the part of your mathematics subject, either in 10th, 12th, or in your graduation, BTech or whatever you have did. Maybe you are from BCA, MCA background, or BSc, MSc, or BTech. It can be. So this is RDD 1, this is having 1, 2, 3, and the RDD 2, this is having 2, 3, 4. There are some common elements between both 2 and 3, right? So intersect result. If you are doing the intersection, what we are going to get as a output? What will be?
2 and 3.
1 and
2 and 3.
1, 3. Okay,
2, 3.
but this is 2 and 3.
Yeah, I have seen 2, 3.
This is looking for common one. Okay, common elements between both. So this, if you have such a requirement where we're looking for, you are having either 2 RDDs or more than 2 RDDs, and you are looking for, okay, which one is the common element between both. Sometimes you may have seen, right? Let's say you are having one RDD with 1000 records and another RDD with some 2000 records, and you are looking, you know that, okay, some elements can be duplicated between both. So you are just trying to find out what is that which is common between both. So you can get like this. You can do with intersect, and you can get, okay, what is the common element, you can fetch it. Any question here from anyone?
Yeah. You are saying that we should avoid to use collect function, right?
Right,
Provide every data to the driver node.
correct.
So I can see most of the function where we are getting the applying any method to the RDD. We
Mhm.
are using this collect only. So is there any another way
No,
like
so
this?
here I am just giving you example for each one individually, right? So I am just trying to show you the output. So that's why I am using collect. Here I wanted to show you the output of this intersection. So I did the collect, but in real time. Let's say I wanted I want to get what all uh, common elements between both of the RDDs. Why I will do collect first of all? In real time, I do not need to check the output, right? First I will get the result, and on top of this result again I maybe I have some more requirement, I will be doing something else on top of this output. But why I will be checking all the time output, and why I will be printing the output all the time? Is it required?
No.
No. And if for sampling, if I want to do also, then I have the option, like I have take, right? I can do some take, I can take the sampling, I can take first. Okay, first is not helping any time because first means only first element. So let's forget that. But just you wanted to take sample for debugging purpose, that okay, what let's say you are getting intersection some 1 lakh records. Out of 1 lakh records in the loggers, means in the, for the debugging purpose you want to collect some uh, element. So you are taking, okay, let's take 5 or let's take 10, so you can just debug, okay, is this as per expectation or not. You can do like that. But in real time, why collect is required? Just to see the output, not required, right? So this is just for the sampling we are doing, for just we are just printing and we are checking how it is behaving. But in real time, this is not expected.
So
In real
here
time, just
only
get the output.
Yeah, here only if I not taking this select, I just
Hmm.
doing intersection between RDD1 and 2
Hmm.
and putting the result into intersect underscore result variable.
Hmm. Hmm.
And then I want to print the value of this intersect result.
Again,
So
you are
how
coming
it
to the
is
same
this?
point. So the thing is, first of all, in the real, I will talk about the real time. Okay. First of all, in the real time, we are not going to collect all the data. We are not looking for the print because most of the time, most probably, on top of this intersect result, you will be having some more transformation. That transformation you will be applied, or if this is the final output, then you are going to write this to your final. Let's say this is the RDD, then you are going to do some save. You are providing with some location. You are just going to save that. And if you want to print it only, then you can go for each. Yesterday we discussed about that, right? You can have some loops, even you can apply some loop. With that loop, you can loop for all of the elements inside this and you can print one by one by one. But again, that is not required. You can think
Yeah.
about first what is the requirement for printing all the output, because in real time this is never required.
For print only we need to use this select, right?
Yes, yes, only to check the output. Okay. So like if you want to simply if you, as you said, you want to print without collect, then you can go for both. Either you can go for each, or here let's say I am okay. What I did comment unnecessarily. So let me do this. Here I will do for testing. For testing, I am saying print test and RDD one intersect result. Intersect result. No, that is wrong. I will do this. Result equal to this. Then result dot take. Let's say I'm saying 5, or I will do 2, and I will do one more print. I will just do result dot for each and lambda.
Screen stuck. I don't know the issue is from my side or
Sorry.
screen is stuck on print statement only.
Let's see that. Yesterday also we see the same, right? Okay. So for this using take, you are good to take this, and with for each, if this is not working directly, then you can have this with the loop and then you can work it. Anyways, in local system, this should work. Okay. Okay. So you can think about some alternatives instead of doing the collect. That is not advisable. Next, moving to further transformation, where we have sort by key. And the thing is, see, here we are talking about more, right? Maybe you are not good with all one. Whenever you are building the understanding, maybe you are not getting 100%. At least you should try once. If not 100%, then maybe you are not confident with all. But you should do more, because most of the time I have seen when we discussed about the in the interview what all transformations you have used, people get stuck with the name of 5 and 10 only. Even 5 also I see that people are getting stuck. That means what? Are you going to complete the project with 5 transformation only? If you are claiming that you have worked with 10 projects, have you done with 5 transformation only? All are around the same transformation, same business logic and all. This will not be right. So you should be at least 10, 20 transformations should be on your tongue. Frequently you can tell about, okay, this was the transformation I used for this purpose. This was the transformation I used for this purpose. So that will be kind of a showcase. You are showcasing yourself. Okay, I have did the variety of tasks and all. So that is going to helpful. Then I let me comment out all this. And this is about sort by key. And for each partition, sample with replacement and all, these are having some different things persist in. Okay, okay, then you have sort by key, which is to sort the RDDs by key. Whenever you are printing the output as of now, this is not sorted. If you are having some key value and you want to do the sorting, you can use sort by key. And then sample with the replacement. This is similar to sample only. Yesterday we discussed already. Then for each partition, whatever partition we are defining the number of partitions, right? So if we can execute a function on each of the partition, let's say you are having the function and you want to execute and you are trying to applying that over all of the partitions of the data. Anyways, if you are not doing anything and you are applying any of the logic that gets implemented, that get applicable to entire partitions only. This is not something like it will be working with a single one, but internally logic gets differ something and that will be behavior will be little bit different. Then we have count. Count is again for getting the count for the data, whatever data you have. Then reduce. Reduce is useful when you are trying to combine the elements of the RDD using a specified function again. And then subtract by key. Here you had sort by key, where you are trying to sort the data with the key, and subtract by key means remove the elements from one RDD that are present into the another RDD by the key. Let's say you are having more than one RDD, and both of the RDD, similar key can be means a similar data can be presented. Then you want to remove elements from one that are already present into the another one by its key. Based upon the key, you can do the subtract. Then persist and cache. Like repartition and collapse we discussed, right? This is also one of the most asked topic in the interview about persist and cache, and this is the major part of optimizations as well. How this is going to help you. Okay, so this will be um, discussion. This will take some time. Okay, so let's start with this sort by key. I will first comment out this and we'll take the sample example. Okay, so when we look at sort by key, you have B1, A2, and C3. This is randomly. A should be first, but here A is in the between, right? This is the key and value is 1, 2, 3. You are doing sort by key. Then what will be output for this? Here, instead of collect, I will do take. I will not do collect. Dot take 5. Anyways, I have 3 element only, but I am doing 5. As I have only three, so it print the three, and I have not used collect because that is a costly operation. Take is fine because I will be getting sample, and sample is enough for the debugging and all. So here I can see A, 2, B, 1 and 6. This is sorted by the key. So any kind of requirement where we are looking for the sorting, we can go with this. Then sample with replacement. This is similar as we discussed yesterday about sampling the data. So sample with replacement, where sample with or without replacement we can take. Again, this comes under the byte transformation. Here, let's assume that we are having RDD with these numbers and then sample with replacement result. We are saying RDD.sample. This is the parameter it takes internally. If you go to its internal implementation, how it has been implemented, then it is asking for the parameters. One parameter is with the replacement, that is the boolean, either true or false. Then fraction. Fraction is the float number you are looking for, the size, and then with or without replacement you can do. Then seed is the optional, you can give any integer number, and based upon the integer number this will be seed for the random number generator. So here we are giving this true, and then this is your number, and then this is the seed. Randomly I have given a number, okay, not with any intention that I am doing this one only. You can change the numbers and all. So this is just for sampling the data. If you see sample with replacement result, we are getting 5. Okay, if I just change this, then if you see value got changed. So based upon that number, based upon the value, it is going to provide you the output. Okay, then we have for each partition. So for each partition, let me take up this. Above also we were trying to use with for each, right? But that is different, bit different. So this is for each partition which executes a function on each of the partition. That again comes under by transformation. Okay. And here let's assume that you are having a RDD. This is the original data, and you are creating this original RDD with 2 partition. Okay. Then for each partition, you are going to apply this any of the logic. Let's say here I am doing some for each of the partition. So for partition RDD.gloom, I understand that with gloom you are having the understanding as of now. If not, you can explore this more. Then dot collect. And for element in partition, this is the partition. Okay. Then print each of the element. So if you want to apply something over each of the partition, then we go for each. Anyways, I will run this directly first. I think that there was some issue. That's why I had commented this. Okay. Element 1, 2, 3, 4, 5. Okay. This was not printing like how we did for each above. It is not printing directly. That's why I had commented. Okay, it's fine. So here you are applying something over each of the partition, then you can. That is for the for each partition. And then you have count. Let me uncomment this as well. Count just to take the count for the data, nothing else. This okay. So count the number of the elements inside the RDD. We apply this over the data frame as well. So this is the element 1, 2, 3, 4. If you do the count, your count will be 4 for each one, each element. This is count result is 4. So you can take the count what the count is. And then reduce. For reduce, we have reduce combines the element of the RDD using a specified function. That function is lambda. Okay. Here you are having reduce, that is your transformation, and using lambda you are going to work out. Let me comment out this to have clear output. Okay, then we are doing RDD dot reduce and lambda xy x plus y. Then this is going to reduce. Anyone can tell me what will be the output for this reduce as per your understanding? Because this is dividing the data between x and y. Means this is your input 1, 2, 3, 4. This data will be getting treated with the x and y, and then finally it is going to do the sum for x and then y. What will be output? Anyone?
Two elements, maybe 1, 2, 2, 4, something like that.
Okay, let's run this. Okay, what is the result? Result is 10. How? 1 plus 2, first this is the x and this is y at very first stage. So x plus y, 1 plus 2 equal to 3. Then this 3 become x and this 3 become y. 3 plus 3 is 6. Then 6 become x and remaining 4 become y. Then x plus y equal to 10. Finally 10. That is how means this is going to reduce. This first two x plus y reduced and that become again a first one, that is the x. Again this will be this is taking the next one as y, and then this will be repeatedly happening until unless this got the final output. Okay. Okay. Then we have subtract by key. Let me uncomment. So for subtract by key, this is going to remove elements from one RDD that are present in another RDD, and it will be doing this based upon the key. And again, this is the part of Y transformation because this is going to shuffle the data. Why shuffle the data? Your data is distributed over 10 nodes, 20 nodes, whatever you have given, worker nodes. And then your data, whenever your data is distributed, uh, some keys are with data node 1, means worker node 1, some keys are with worker node 2, and likewise data has been plushed. So this needs to compare and match with all the nodes. Okay, this is the key. This is the key A. Is this key existed to key, worker node 2, 3, 4, 5, whatever we have. So this is going to check everywhere, and then this will be doing the subtraction because this has to subtract. This has to remove element from one RDD that are presenting to another RDD. So without check how it can remove, it has to make sure. Then only it can come up with the final output, final and perfect output. Okay. Because of that, this is going to communicate with all the data. So data shuffling will be happening, and that's why this is the part of Y transformation. So let's assume that you are having one RDD that is having A and B. You have another RDD that is having B and C, and then you are going to apply this subtract by key. The output is expected. What will be the output? You just tell me.
A and C?
Let's see that. Subtract by key A1.
So only one from the RDD one is returning, not the RDD. Okay. Just
Yes,
removing the.
correct. So this is removing elements from one RDD that present in the another key. So in this RDD, it was impacting with this B, right? This was the common one. So this was duplicating. So this removed this, but this is not caring about whatever you have additionally in the RDD too, because this is not join. If join, then it will be caring for all, right? Then we have next one, persist and cache. This is something a wide topic to discuss about. Okay. So persist the RDD in memory for future actions. That is again Y transformation depending upon the context, and generally it refers to storage. It can involve shuffling when data is persisted to disk. And if we have next to cache, this stores the RDD in memory for efficient reuse. Wide, this is again wide transformation, and this is similar to persist only. This is also persist, right? But typically involves storage management, but can involve wide operations under certain conditions. By default, for cache, persist level is memory and disk. Okay. So what happens? Let's say you are having you are processing with some 100 GB of data, and from that 100 GB of data you are doing a join, then you are doing some filter, then you are doing some other complex transformation. What is the output you got after that complex transformation? That same output you want to use 3-4 times, multiple times, in different transformation, different use case, or different stages. Then if you can persist that output, then all the time you are not going to apply that complex transformation that is taking some time, and then it will be working out. You can cache that, and once you cache that, then that output is saved for you in memory, and you can reuse that, right? Reusability. You are getting the point?
Yes.
Is just like normal cache where we're storing something in memory if you are frequently using it.
Right. So let's say you are getting that output after some complex join, and that complex join is taking some half an hour. Just assume. Then if you need the similar output, same output 4 times, 4-5 times, then 4-5 times, if you will call that join and all, always this is going to take some time, right? Half an hour. So you can save that output, that intermediate output you can say, and once this is cached, this will be available to the memory, and you can use it for your reusability. By default level for this internally, it is memory and a disk, but it will try to keep in memory if that is fitable. Like let's say you are having some 1 GB, 2 GB, then that is fitable. It will be good to have the memory. But if your data exceed with that particular defined uh, amount, then that will be going to memory and disk. So default level configuration is memory and disk for this. For persist, this is again for saving the data only, how you are going to persist the data. And in Spark we are having multi-level of persist level, either with the disk only, memory and disk, and memory only with some serialization and all. Okay, so anyways we will be discussing that with very much detail. Okay.
What is the
uh,
where to use persist, where to use cache?
okay, what as per your understanding, what do you
Sorry
understand?
to interrupt. So because my understanding is, suppose even in the cloud databases also, so if you are running a query multiple times, by default the query engine or something catches that SQL query's result in the memory, so that if you are firing that query again, it will bring that. So that is similar to cache. But
Hmm.
then what is the difference between cache and persist then?
Okay, let's say you are having some 20 GB, 50 GB of file. Okay, and you are trying to read the data, you are trying to process the data. If you are, if you will be doing all the processing with in memory only, there are the chances of failure, right?
Yeah, out of memory. Yeah.
If you are having good amount of data, then you can do persist. You can think about persisting with disk. Then some data will get managed with disk also, some data will get managed with memory. So whatever fitable by the Spark means as per Spark, Spark is going to take care all the things internally. So as per Spark, what is fitable into the memory, that will take care. Whatever exceeding from memory, that will be simply dumped to disk, but it will not fail without a memory exception. So this is helpful for the huge amount of data. So see, if we talk about particularly for the Spark, because Spark you are going to use everywhere, either you are talking about your GCP, or you are talking about Azure or AWS or Hadoop concept. This is Spark is same, right? Only your platform is different. So when we talk about persist and cache, both are used to store the intermediate RDDs or the data frames in memory or disk for reuse and improving the performance by avoiding recomputation of the same data. Now, if we talk about usage wise, then this cache is simplified syntax for common use case, and mostly we use for in memory. Whenever data is small and it is fitable to in memory, we can use for the uh, to avoid recomputation and all. And for advanced use case where custom storage is needed, we go for the persistence. Okay, so when we go in persist we have some different memory level. One is memory only, then we have memory and disk, memory and disk, then we have disk only, and memory only, sorry, and then memory and disk, memory and disk, then offheap is also there. Okay, so if you talk about when we use persist when we need more control over the storage level, because we have lots of options. When data should be stored only in memory, like memory only, to avoid disk input output. Whenever you are going with memory only, that means a simple. There is no interaction with the disk, and you are going to avoid all the input output operation. But this is possible only if you have a small amount of data, right? Your larger amount of data, let's say you are dealing with 1 TB of data, you cannot assume that 1 TB of data you can work with memory only, not possible. So that will be the condition. Otherwise, when data should be when we are thinking that data should be stored only in memory, then you can go with memory only, and you can avoid disk input output operation. When data should be stored only on disk, if memory is limited, whenever your memory is limited, let's say you are dealing with 1 TB of file, and your memory, your worker nodes and all are limited with some 10 GB, 20 GB and something. And whatever you are doing, if you smartly develop your code, this is not going to fail, because you are just simply trying to read the file of 1 TB, apply some transformation, and you will not be doing the so, and you are not going to do collect the data and all, and finally you will be writing the data. So smartly you can manage that. Okay, in that case, whenever you have the memory limitation, you can go for the disk only. And when serialization, you think that okay, if I apply the serialization, then this can more help, because it is going to help save. Help with the save space also, right? Then you can choose memory only Saturday and memory and a disk Saturday. If you think that okay, I have some amount of data, which let's go with memory and disk. If fitable to memory, Spark will take care. If not, if something is exceeding, then Spark will dump that to disk, and my code is not going to fail because of out of memory exception. Then you can choose this. So this is providing you flexibility, more control over the storage level to manage with the data, huge amount of data. And if you have a small amount of data fitable to memory, then you go with cache, because for cache by default storage is memory and disk. This is for cache. Okay. And for persist, you have multiple options. So for the cache one, by default, Spark will try to dump the data with memory only. And if that is not fitable, then this will be going with alternatively to have the exceeded data with the disk. For cache, we can say this is the simple where the default storage for the cache is memory and disk. When the data fits into the memory or can partially spill to the disk without recomputation, then we can go for this. And for any of the iterative algorithm, let's say you are working for some uh, let's say for example, nowadays machine learning Gen AI is trending, right? So let's take the example of the same. Let's say you are working for some iterative algorithm with some machine learning and all, where data is reused multiple times you are going, means you are training the data, then the trained data multiple times you are going to reuse in your model. So you can use this cache, or in simple example also, if you are doing some simple POC, you are doing some aggregation, you are doing some transformation, and that output you are looking for multiple time, then also you can go for the cache. Okay, so this is about this, and for now I will be going with the simple one only, but tomorrow I am going to have a deep explanation on this
Just
cache
a,
and
just
persisting.
a, small code. You don't need to explain that detail.
Mhm.
Suppose in case of cache, first it will try the memory. Then if
Correct.
got overflows, good row. But is there any way we decide how many the 30% will go 10% by default?
You
It
are not.
checks.
You are not deciding that.
Okay.
Let's do it with this Spark understanding only. That will be by default with this Spark.
Yeah, got it.
Okay. So here we have this is for subtract by key. Let me comment out this. Okay, then we have persist. So what we are doing with the persist? If you are calling this simple persist, then this is going to persist your RDD, and when we are going for the cache, then we are calling this cache. But the thing is again, whenever we do, let's say first talk about cache, this caching. Let's say you did some join, then you did some filter. This is the wrong. We should do first filter. Let's say you were applying some filter, then with final data you did some join, then again with final data you did some data manipulation, and this is the output you are looking for minimum 5 times in your application. Okay, means 4 5 times you are going to use this. Then if you are caching this, then what this is the, let's say, output equal to output equal to. Then what you are doing, output dot, you are applying this cache. You are caching this, and assume that this output was something 2 GB. Then this 2 GB, this is going to occupy your 2 GB memory from your nodes, right? And until you are using this, let's say 5 times you are looking for this output, you can reuse this. And once your task is done, further you do not need this data, then you should not forget to uncache this, means unpersist this. Otherwise, if this output is of 2 GB, by default this will be available, and unnecessarily this is going to be available and move out throughout the application, right? Because until unless Spark is completing the application is getting killed, or getting killed means when application is completed, then all the JVMs and all will be cleaned up, right? So by that time, this data will be, this intermediate data will be available. That is not needed unnecessarily. Why you are occupying this 2 GB memory? So until unless you are looking for this, take this, and once you are, let's say you used for first time, second time, fifth time also. Okay, then finally unpersist this, free up the memory. If you are not freeing up the memory, then you are creating the issue. That should not be. Okay. So this is something like whenever you are doing persist is different thing, because you are you are trying to get the control, more control over the data, how you are with the processing time, not only for the reusability, for the processing also, for storage also, for computation also, management, uh, um, management for the entire data. You are taking care for that. This cache is mostly you are using for avoiding recomputation and all, if you are using the same data, same output multiple times. But it is going to take some additional memory, and that memory will be uh, for all the time until unless you do unpersist. So whenever you are thinking that you are done with your job and going forward, I do not need this output, then simply you do unpersist. That will be again making your processing faster. This otherwise this will be impacting the performance and all, because let's say at some condition some reshuffling is happening, data shuffling is happening. Even this 2 GB data is not required, but unnecessarily this is also going to shuffle, right? So this will be impacting in multiple ways. So whenever you are done, simply do unpersist. So this is for just reusability of the intermediate data, not the source data and all. If sometimes it can be source data also. Source data, like let's say you are having some customer data, and for that customer data you are trying to you are trying to join with some country details. You are having some data which is having country code and all. So either you are going for broadcasting, that is fine. Let's say you are going for broadcasting, and on top of that you are trying to do the cache, and then with that cache you can do the reusability and all. So sometimes you can go directly with the source data, and most of the time it will be with your intermediate result, intermediate output only. Any question here? Anyway, this will be tomorrow's discussion part also, this cache and persisting with some examples. Anyone has any question?
No.
Okay, then I will not share exercise for persistent cache. Okay, tomorrow I will share once we are done with that in details. For remaining one, I will be sharing the exercise. You can go with that. Okay, then let's meet tomorrow. Have a good day. Bye.
Thank you. Bye.